What we're learning about today is something completely different, and it's a part of your calculator and a part of math you've never heard of before. They're called matrices. Okay, that's the plural of the word matrix. A matrix is a really advanced mathematical skill, but we're going to be solving them using technology instead of by hand. To solve them by hand is like an entire class in college you take for a semester. We're not doing that. We're going to use technology to solve these matrices. A matrix is simply a rectangular arrangement of numbers. So we're going to take a system, and we're going to take the numbers from the system of equations, the x's, the y's, and today we're also going to have z's, x, y, and z. And we're going to put them in a rectangular arrangement. The dimensions of this matrix are always m times n, which m is the number of rows, so rows, and n is the number of columns. So when we talk about the dimensions of your matrix, which we will need to talk about for using your calculator, we're going to need to know the dimensions, row by column, row by column. The elements of a matrix is literally just telling you about the numbers in a matrix. So we're going to be putting numbers in a rectangular formation, but we have to make sure that when we write what's called an augmented matrix, which is what we'll really be focusing on, that the numbers are written in standard form, which is ax plus by plus cz equal to big D, okay? We have x's, we have y's, we have z's, and then we have constants. So these are going to be advanced things that we're going to be doing on our calculator. We will come back to the steps. The steps are here for you to know how to do this in your calculator. There are a few things we're going to do before we start talking about the steps, though. So I want you to flip this over, and I just want us to write a few augmented matrices so you know what I'm talking about. We will come back to this. The steps to solve an augmented matrix, so again, this is what we use when you're asked to solve something, is, first of all, write the augmented matrix, which we just did on the other paper. So that would be step one, is to get the numbers on our screen. In your calculator, and I'm just going to walk it through on here, then I will show you on your calculator. Do you see the word matrix somewhere on your calculator? M-A-T-R-I-X. Does anybody see it? What button is it on top of? It is on top of, yeah, x, is that x to the negative 1 power. That's the button you're looking for. It has the word matrix above it. We're going to be using that tool. You're going to enter the augmented matrix into your calculator by doing the following. We go to the calculator. We go to second matrix. It should look like this. Are we there? We've got A, B, C, D, E, F, G, but we want to edit a matrix. So we're going to go to the left 2 times until we get to the edit screen. Are we on the edit screen? We're always going to be working in matrix A because we will only be doing one matrix at a time. When you get to college or learn about linear algebra, you'll be doing more at a time, but whatever, it doesn't matter. We click enter, and it's going to ask us the first question. For this matrix, what are the dimensions? Okay, so if we were solving one of our 3 by 4 matrices, we would literally say 3 and then 4. And do you see how it like builds a matrix for you? It's now got you in the first spot of the first row. We would be typing numbers in. So we're just going to type whatever number right now because we're not actually doing an example. So we would press 5, press enter, and then, I don't know, maybe it said 9 for the Y next, and then we press enter. You see how it's moving across the top row, giving me all of the numbers? It doesn't have the bar, but you know the bar is there. When you finish the first row and press enter, it pops down to the second row. This would be, I don't know, I'm making up numbers here. You can put fractions. You can put negative numbers. You can put whatever you want to in here. But every time you press enter, it's going to place the number in the matrix. Okay, once you have the matrix completely filled up, we look back at the instructions on the page. The instructions say, so we've made it here, we went to edit, and then we edited letter A. That's the one we're editing. We entered all of the elements as well as the matrix size, m times n. And then we need to quit because we want to get out of the editing screen for the matrix. So you're going to press second and then quit. Can anybody find the word quit on their calculator? It's above mode. So maybe make a note for yourself right there that this is above the word mode. So we would press second, quit, to get out of the matrix edit screen. Should go back to your normal screen. Following the steps some more, it says to press second matrix one more time. So we press second and then matrix. Cursor over to the word math. So we want to go to the math screen because we want to do something with this matrix. What we want to do is called RREF. Circle, highlight, star, and underline. That part right there on your notes. RREF. Unfortunately, it's not one of the first things you see. Look how far you have to scroll to find RREF. I'm scrolling. I'm scrolling. I'm scrolling. I'm scrolling. I'm scrolling. There it is. Not REF, RREF. So it's letter B. We press enter. It's going to put the RREF command on our home screen. But we need to place our matrix in that command. So here's what I'm telling you, these steps are long. We go back to second matrix. We choose option 1 because we want to put matrix A in there. We press enter and see, look, it puts matrix A there. When you press enter one more time to tell this command to go, it's going to do a bunch of stuff to your matrix. This is what we want. The stuff that comes out of the ending tells you your solutions to a system. Let me explain what these look like. If we, after we, put it all in there, we will get one of 3 options. If your diagonal line is all ones, do you see how there's a diagonal line of ones right there? Okay, maybe there's only 2 of them, maybe there's 3 of them. There should be a diagonal of ones. There's a diagonal of ones. You're going to have a solution to this system. Most matrices have solutions. Okay, what you do is you take the numbers on the side of it and you label them X and Y. That's your coordinate answer. We would answer the solution to the system is 1, 2. I didn't have to do any elimination. I didn't have to do any substitution. I found the X and the Y variable. If your diagonal line is not all ones, do you see how on this example, and this example, the diagonal line is not ones? There's a 0 there. Oh, I need to move my mouse. You have a special case. You would not have a solution normal like a number for these 2 graphs. When you have a diagonal that is not all ones, you have to look at the bottom row. If the bottom row says this or this, your matrix is telling you that 0 is equal to 1. Is 0 ever equal to 1? Like literally, is the number 0 equal to 1? No, so we would put a little line here like this. We'd say it's not equal to 1. And you would answer this as no solution. If your diagonal is not all ones, but the bottom is all zeros, do you see how this one has all zeros? You're saying the math sentence that 0 is equal to 0. Is that true? When that happens, you would answer infinitely many solutions. Okay? Those are your options for today. And what we're going to be doing is we're going to be trying to find either one solution, an X, a Y, or X, Y, Z, or no solution or infinitely many solutions. I am cool if you shorten IMS or shorten infinitely many solutions to IMS, because that's a lot of letters. IMS, infinitely many solutions. Here's a system. Last class, we would have solved this by hand, right? We multiply by some number, we do elimination, maybe we substitute, blah, blah, blah. This is a new way to solve with technology called matrices. What we do to write an augmented matrix, remember that's the rectangular version of numbers, and then we're going to state the dimensions, which is the rows by columns. All you need to do is take the standard form equation right here, and all of the numbers, you just pick them up and you put them in the rectangle. So watch. This matrix is going to be 5, 6, and 13. And then the next row is 8, -2, 2. Where did I get all those numbers from? Do you see that 5 went right here? And then 6 came right after? And after the big line, which represents what? Equals, this is the number 13. And then I have 8. Then I have -2. And then I have 2. Basically, there are no variables in matrices. You're just picking up their coefficients and putting them there. The only way that this can get any harder than literally putting them where they belong is if it gives you an example like 2. I want to do number 2 and I want you to tell me what I did. So here's the matrix for number 2. 7, -4, -5, 2, -2, 13, 45. Yeah, remember, they have to be in number order, which means x's, y's, then z's. This x did not come first, so I just make sure I look for the x first. That has to be the first number I use. So the x, make sure it goes first, and the y, make sure it goes second. Do we see that? Now, the only other thing in these problems that we do is we state the dimensions, but all we need to do is count the number of rows and the number of columns we're using. In problem number 1, how many rows do I have? How many rows? Rows are like this. 2. How many columns do I have? Columns are like this. 3. This is a 2 by 3 matrix because we have 2 rows and 3 columns. What are the dimensions of the second matrix? Also 2 by 3 because we have 2 rows and 3 columns. Cool. Let's kick it up a notch because we get the filling in thing, right? Some systems, like examples 3, 4, 5, and 6, have 3 variables instead of 2 variables. No big deal. You write the matrix in letter order. Number 3 would be -2, 4, -1, -14. 3, -2, 2, -3. 6, -3, 1, and 13. Do we see, again, all of the numbers just are coming out of the equation. Little bonus question here. Why is this here? I don't see a -1 here. The coefficient, when it's invisible, is always what number? 1. Okay, so if you don't see a number there, you know that it's 1 next to that letter. Awesome. I want you to try number 4. Oh, wait, we didn't state the dimensions. Back up. Boop. What are the dimensions of this new matrix? 3 by 4. We have 3 rows and 4 columns. Now your turn. I want you to try to write the matrix for number 4. This one has, make sure it's in letter order. Make sure you know that. Okay, here's what we should have written for number 4. We have 1, 3, -9, and 14. 4, 5, -2, 11. -4, 3, 1, 2. Oh, snap. Is the third equation written in standard form? No. Remember, it always has to go x's, then y's, then z's.
So it's the 5 and the -2. So the z's go last.
Oh my gosh, y'all are so right. I totally did that on purpose to make sure you're paying attention. What should this number be? -2, and this one should be 5. Because again, the z's go last and the y's go in the middle. See how easy it is to make a silly mistake? Classic. What are the dimensions of this matrix? 3 by 4. That's the one you're going to see the most because we deal with 3 variable systems in this class. So that's going to be the most popular dimensions right there, 3 by 4. I'll do example 5 with you and then you'll have number 6. If I were writing the matrix for number 5, it would be 3, -6, -2, -5, 1, 1, 1, 19, 4, -9, 0, -2. Whoa.
The second one, when it's like that, when it all have letters, then you can just put 1. You don't have to go in order.
Well, correct. Remember, this is 1x, 1y, 1z. So the coefficients are still there. They're just invisible. But I have a question for you. Where did this 0 come from? There's no z at all. Not that z's coefficient is invisible like this one. That means there's one z there. Are there any z's at all in that last equation? No, so that means it's like we have a big old 0 times z. No z's at all. When there's none of the letter in that matrix, in that equation, you put a 0 in your matrix. Yes? Can you guys try number 6? That one's for you. Okay, here's how we should have done this one. Let's see if we got it. Let me make sure I got it. This is 0, 3, 4, negative 12, 6, 8, negative 9, 32, negative 1, 5, negative 2, and 1. Did y'all remember that if there are no x's, like in that first equation, that you put a 0? Awesome. That's about as tricky as it can get. Unless we have a problem like 5 and 6. I mean, 7 and 8. Oh, we didn't do the dimensions for these. What are the dimensions of these matrices? 3 by 4. Again, because we have 3 rows and 4 columns for both of them. Okay, great. So here's again, the only way it can get any more challenging than this to write a matrix is if the equations look like number 7. What do you notice about what's happening in number 7? Yeah, we got numbers all over the place. In the first one, that constant of 37 is on the wrong side. Remember, that should be over here. And then like on the second one, the y is out of place. That should be over here. And then over here, we got a z out of place. We got a constant out of place. We need to fix this system before we write the matrix. So we're going to rewrite the equations in standard form where they go x, y, z number. And then we can do the matrix. So in the first one, you guys told me that the only thing that needed to move was for the 37 to come over here. If that 37 hops over the equal sign, what happens to it? Changes to negative. So this equation would look like this. It would be 2x minus 7y plus z equals to negative 37. There's my x, my y, my z, and my number. In the second equation, you guys told me that the y was out of place. So if I come and I plop it right there, is it crossing the equal sign? Is it crossing the equal sign? What happens when the y turn?
The y out of place. Don't put the y in the front though. Put it in the middle.
Yeah, put it in the middle. But when it crosses over this equal sign, what happens to it? Becomes a negative, changes sign. So this second equation would be 10x minus 4y minus 3z equals to 9. Do we see that? Okay, in the third one, you guys told me a bunch of stuff's out of place. Where should I move this negative 13?
To the other side.
And where should I move this negative 2z?
To the middle.
Okay, great. So we're going to do both of those flips. We're going to flip-flop them, which means I would have 5x. And how many y's? 0. So we're going to do plus 0y, just so we know what number goes there. We moved the 2z over. What happens to it? If it's already negative and you move it across the equal sign, what does it become? Positive. Very good. This is positive 2z. And then if I move that 13 to the other, negative 13 to the other side, it becomes positive. Oh my goodness. Okay, so they gave us the matrix or the system out of order. They were not in standard form. Really not in standard form. They're on the wrong side and everything. We've fixed it. Can we write the matrix now? Yeah, my matrix would be 2, negative 7, 1, and negative 37. 10, negative 4, negative 3, and 9. 5, 0, 2, and 13. As a note for you, if you go online and you Google around for help on this lesson, you might notice, and don't do this on your paper, but I just want you to watch for a second. You might notice that some mathematicians and some people online do like a dotted line here. That's okay. That's the same thing. My professors in college all made us do a solid line, so I'm stuck doing that because that's what my training was. Is that okay? So if you look online, somebody might just have like dots on there, and that's fine. That's the same thing. That's showing you where the bar goes. Okay, can you guys do number 8 for me? I want you to fix the matrix, fix the system, and then write the matrix. I'll give you some time to work on this because it's kind of long. You got it. You got it. Here's what we should have gotten whenever we rewrote the system. This should be 9x minus 1y plus 0z's equal to -4. Now, again, I told a few people this. You didn't have to put this for it to be considered correct, but I like seeing the 0 because it helps us remember what's supposed to be there. The next one would be -2x, positive 4y, positive 8z equal to 3. This -2 came from this 2x being moved across the equal sign, so it changes signs. The last equation would be 5x plus 2y minus 8z equal to what? 0, because there was nothing left over there. Very good. We take the z's and we move it across the equal sign. Cross the line, change the sign. Awesome. When we write the matrix, it should have looked like this. 9, -1, 0, and -4. -2, 4, 8, and 3. 5, 2, -8, and 0. Awesome. So writing matrices from systems. Amazing, we got it. The next step is to learn how to solve these systems. Now, last class we solved systems. That was the substitution and elimination. But we're not doing it by hand today. We're going to do it with technology. Okay, so here we go. We're going to now not only just write augmented matrices, we're going to use all of those steps from the front pages of the notes to solve them. So today is very nitty-gritty with solving. So we got to hang on to the steps. First things first, we want to write the augmented matrix so that we know what we're going to be typing into the calculator. So for number 9, the matrix would be 2, -5, 1, and then -5, -3, 4, -2, 1, 6, 1, 4, and 7. We haven't lost how to do that, right? Does that make sense to us still, how to write it? Yeah. Great. Now it's going to require a bunch of typing in your calculator for you to be able to do it. So everybody follow along with me on this one so that we can do this together. So I am on my calculator. I'm going to go to second matrix, which is the x to the -1 button. I want to go edit that matrix because I actually want to put the numbers from this problem in there. Yeah. So it's still a 3 by 4 matrix because we have 3 rows and 4 columns. But in the first row, first column, what number do I have written on my paper? 2. So I'm going to press 2 and I'm going to press enter. It will overwrite it. So you don't have to delete anything. You just type over it. The next number is -5. And then 1. I'm getting these numbers right off my paper. And then -5. The next row would be -3, 4, -2, and 1. And then I have 6, 1, 4, and 7. After I've typed it all in, I need to just get off of this screen. So I want to quit this screen. Where was the quit button? Above mode. I press second and mode so I go back to the regular home screen.
I thought we put second and what?
Mode. Yes. Now that we are at the home screen, we're going to press a whole bunch of buttons. Here we go. We're going to press second matrix. We're going to go to math. And then what was the command I wanted? 2 R's. RREF. It's letter B, if that's easier for you to remember on this calculator. We go to RREF, and then we're like, yes, that one. Press enter. No, we don't have to quit this one. It's waiting for you to tell it what matrix to put in there. So our calculator should say RREF and then the matrix A. So we need to put the matrix A there by pressing second matrix and then option 1, which is A. When we press enter, we first look for a diagonal of 1s, and then we'll know what type of solution we have. So if I press enter on this, this is what mine looks like. Do I have a diagonal of 1s? Yes, I have a solution. Just because these are our notes, this is the only time we'll do this on this notes. I want us to write that answer matrix just so we know what's happening. We would have gotten 1, 0, 0, -3, 0, 1, 0, 1, 0, 0, 1, 6. That's exactly what my calculator told me. I look for that diagonal of 1s, and I know then that this is x, this is y, this is z. So you answer a 3-variable system with 3 variables. Instead of just an x and y coordinate, you would answer x, y, z. What, 3 letters in a parentheses? Yes, it is a 3D system. Instead of just by 2 dimensions, x and y, this is x, y, and z. We are plotting points in 3 dimensions, which is very cool. On number 10, start off by writing the augmented matrix and then solving it. If you get the diagonal of 1s, remember the numbers on the other side of the bar are your solution, x, y, and z. Okay, if I were doing number 10, so those of you who are ahead of me, just keep going. If I did RREF for number 10, which is called, if you're interested, it's called row reduced echelon form. That's a lot of words. We're going to call it RREF. If we've done RREF, this is the matrix my calculator would have shown me. Is this a diagonal of all 1s? No, so I know it's one of my special cases. We look at the last row only. The last row right there is trying to tell me that 0 is equal to 1. Is 0 ever equal to 1? No, so how do we answer this one? No solution. Okay, if you did not get this when you did RREF, that literally just means you made a typo somewhere. And it's so easy to make a typo on these because you've typed a lot of stuff. So slow down when you're typing and make sure you got it right. We're going to keep going. Go ahead and do number 11. You got it. And if you get 11, go for 12. On number 11, hopefully I'm not cutting off your thinking. When you're doing this, we have the matrix 4, 1, 6, 2, 2, 2, 4, 1, negative 1, negative 1, 1, negative 5. When we do row reduced echelon form, the RREF in the calculator, we would get this. And this is absolutely fine for you to answer for me in decimal form. But here's something that's really cool. In your calculator, how do you normally change a decimal to a fraction? Does anyone know how to change a decimal to a fraction? Yeah. Math. Click the math screen. What is the word?
You click on math.
Math frac. Did you know you can math frac an entire matrix? Which means that you could actually rewrite this matrix as the following. It could say, and these will both be correct, but if you do that in your calculator, this is what it would end up saying. 5 over 2, 1, and negative 3 over 2. So if ever you're asked specifically for fraction answers, or you have decimals that you would have to round, which means I would prefer the fraction, you can math frac it. So maybe write that down for yourself, math, and then it's the first option that says change to a fraction. I don't particularly care, but there may be a time on a test that you get decimals and the answer choices are in fractions. So you just need to know that. But either way, those are the same thing. Decimals are fractions and fractions are decimals. It's just whether you have to round or not. Yeah. So for this one, we would have written the matrix, negative 2, 4, 1, and 1, 3, negative 3, negative 1, 2, 5, negative 1, negative 1, and 8. When you do this, and I'll show this one on the calculator because I think that we need to see another example maybe. We go to second matrix. And we go to edit. We want to edit. Okay. So we edit that one to be our numbers. It'd still be a 3 by 4, so my dimensions are okay. So I go to the first row, and I want the numbers negative 2, 4, 1, and 1. And then the numbers 3, negative 3, negative 1, and 2. And then I have the numbers 5, negative 1, negative 1, and 8. Okay, I quit. I go to matrix again. What am I looking for on the math screen? RREF, it's letter B. And then I need to put that first matrix there. When I press enter, it might get a little ugly. So let's math frac this. Right after doing this, if I know I got a bunch of decimals, I'm going to press math, and then I'm going to press frac. and then press enter. So it's going to change my answer to a fraction. We now have the augmented matrix that looks like what's seen on your screen. 1, 0, negative 1/6, and 11/6. Yikes. 0, 1, 1/6, and 7/6, and then 0, 0, 0, 0. Is there a diagonal of 1s on this one? No. When there's not a diagonal of 1s, we know it's one of our special cases. Diagonal of 1s means an actual XYZ answer. When there's not a diagonal of 1s, we look at the last equation. That last equation is saying 0 is equal to 0. Is that true?
Yes.
Does 0 always equal 0? Yes. Amazing. How do we answer 0 equal to 0? Not what you guys said because we got distracted by Gene's people. What is 0 equal to 0? Infinitely many solutions. IMS. That means any number you plug into that system will work. Awesome. Amazing. Last example that we have is a real-world example. Now, we struggled with the real-world examples last class because writing it was easy, but solving it was hard. But now we have matrices to be able to do that. So we're just going to write the augmented matrix. We're not going to write the system, but we're going to make sure that we know, and I'm telling you this right now, that X is going to represent the small candles, Y is going to represent our medium candles, and Z is going to represent our large. In math, by the way, this is just a cool little mathematician thing. Do you know how the number 2 and Z's can kind of look really similar? Yeah. Mathematicians always put a little line on their Z so you know it's a Z and not a 2. So we have small, medium, and large candles here. Our fundraising company sells these 3 different sizes of candle. For the first order that you sell, it consists of 2 small candles. That means that's 2 X's. 1 medium candle, 2 large candles for $58. Do we see how I took the small, medium, and large and put them where X, Y, and Z go? For the second sentence, it says the second order consists of 3 small candles. Where should the number 3 go? The first spot, second spot, or third spot? First one, because we said X is the small. And 1 large candle. Where should I put the number 1? In the second or the third spot? Third. For a grand total of $39. I got to put a 0 there. Fabulous. We didn't sell any mediums. 0 mediums. The third order consists of 4 small candles, 1 medium candle for $44. How many large candles, though? 0. Fabulous. So now we have this very complicated system when we're trying to figure out the cost of each one of these candles. Bless you. We can use RREF to do that. I want you to do this one last one for me. In your calculator, go ahead and solve this matrix. Here's what my matrix would have looked like if I did RREF for this. Because there's a diagonal of 1s, what does that mean? One solution. Now, what is the solution? No, it's all the numbers on the other side. 8, 12, 15. Great. That's how we actually answer these. But in fact, because this is a real-world problem, just like last time, I need you to give me the answers back in real-world scenarios. So question, how much does a small candle cost? How much does a medium candle cost? $12. How much does a large candle cost? 15. That's what we labeled as X, Y, and Z. Coordinates are always X, Y, and if possible, Z. X, Y, and Z. Fabulous. So again, on your homework, I made some typos. So make sure you change these. Typo number 1, on question number 3, go look at question number 3. It says -8. Do you see it? Or sorry, it says positive 8x on that third equation. Change that to -8x. My bad. That should be a negative. On question number 5, that was number 3. The third equation should have a -8 instead of a positive 8. That's the third equation. On number 5, it says on the second equation, it should read 5x plus 4z equal to 8y. So you change this from a y to a z. Again, my bad, straight up typos. The second equation. On equation or problem number 7, the first equation should say 4x plus y plus 6z equal to 7, not 74. So please get rid of that 4 right there. My human was really showing yesterday. And then the last typo on question number 10, the first equation should say x plus y plus 4z equal to 7. It's missing the z. That's on me. Those are my 4 typos. 4z, yeah. It just says 4. It should say 4z.
Okay, I got the first one. The first one.
The first one, here, I'll just write the third equation on number 3 should say 6z minus 3y minus 8x equal to 1. My bad.